Hi everyone, this is Dr. Meena Biga from Sri Shanmugha College of Engineering and Technology. Today's in this session we will discuss about calculus in everyday life. So how calculus is applied in our day-to-day life. That is a topic that we are going to say now. So the first example I have given is a swimming pool. When you consider a swimming pool that is filled by water dripping from a tap, so you could see the picture. Just I have given a picture to you. At any point in time, you can theoretically add up small drops to find the total volume of water in the tank. This is an application of integral calculus because it uses small droplets of water to determine the whole volume of water at any point in time. So, small droplets will constitute the volume of the swimming pool. So, this is an example of calculus in everyday life. On the other hand, if you would like to know the rate at which the water is filling the pool, you could count the number of drops per second that drip from the tap. So this is actually differential calculus since it considers how small droplets fills the tank without actually determining the total volume of water in the tank. So the rate at which the water is filling the pool is called as differentiation. So it is what differential calculus is actually. So imagine you have a piece of cardboard of which you already know the length and width of the cardboard. You want to build a box with the cardboard and you are trying to determine what dimensions will give you the maximum possible volume for the box. So this is the question. Just we are imagining that we have a piece of cardboard of which we know the length and width we know. We want to build the box with that cardboard, so we are trying to determine the dimensions. What are the dimensions that are required will give you the maximum possible volume for the box. So this can be solved by using differential calculus. Let us start with a small box with a length, width and height of 1 unit. Keep increasing the height, width and length in small increments with small increments until you find the ideal dimension using the piece of cardboard where the volume will be the maximum. Here you are considering small changes in dimension to identify the ideal dimension. So this is what we are doing with the cardboard. Uh, so that constitutes actually the differential calculus with small units, with small things if we are able to do. So that constitutes the differential calculus. Now, how this calculus is used in business. I have given an example. A grocery store owner wants to find the optimal time to display berries. She knows that berries will sell better if they are on display at a certain time, but since they are perishable, she doesn't want to leave them out all day to ensure they are on display at the ideal moment. How can the owner find the right time to display her product? So, this can be solved using differential calculus. The storekeeper could record the quantity of the product sold at different times during the day, then identify the time at which the product sold the most. Here she is considering small increments of time to identify the rate of sale. So on the whole, if she wants to sell, so she is considering small units, that is per day, how the berries have been sold. So all those things considering, so that is called as differential calculus. So this is how differential calculus is applied. Now units in a factory. If you run a factory which manufactures a product in 50 steps, that is, there are 50 tasks to perform to create 1 unit of a product. So, using integral calculus, we can find out how long it takes to build each unit. Just find the time for each task, then add the individual times to calculate the total time for all 50 tasks. So, whenever we are integrating, we are combining small tasks put together, we use integral calculus. In search engines, so we all are using search engines. So algorithms are used every day by major search engine companies to help refine searches for the person behind the keyboard. Algorithms are calculations used to compile a large amount of data and variables into an equation, spitting out the best possible answer. So we all know this. These algorithms are what make search engines so adapt to at finding the precise answer quickly. They take into account variables such as the user's geographic location, web history, and how useful other users have found similar web pages to create an appropriate search result. So all of these variables are utilized to define the rules and constraints of sequent calculus equations that produce the most logical and effective results. In predicting weather models, So weather is more accurately predicted than ever before nowadays. Part of the improvement is thanks to technology such as computer modeling that uses calculus and is able to more meticulously predict upcoming weather. These computer programs also use types of algorithms to help design assign possible weather outcomes in a region. So much like in the computer algorithms, weather forecasts are determined by considering many variables such as wind speed, moisture level, and temperature. Though computers do the heavy lifting of shifting through massive amounts of data, so the basics of meteorology are grounded in differential equations, helping meteorologists to determine how changes in the temperatures and pressures in the atmosphere may indicate changes in the weather. Improving public health. So, how calculus is applicable to the health industry? In the field of epidemiology, the study of the spread of infectious diseases relies heavily on calculus. So we all know that during the pandemic situation, the rate of increase of the COVID virus was rapidly it was increasing. So basically, all those analyzation and the data predictions were done based on the calculus. Such calculations have to take three main factors into account: those people who are susceptible to a disease, those who are infected with the disease, and those who have already recovered from it. With these three variables, calculus can be used to determine how far and how fast a disease is spreading, where it may have originated from, and how to best treat it. Calculus is especially important in cases such as this because rates of infection and recovery change over time, so the equations must be dynamic enough to respond to the new models evolving every day. So this is what the main applications that we are using calculus in everyday life. Thank you.